All right. So, if you have any questions about the guided reading, reach out to me. It followed along really easily. There was a lot of review in there, and then there was some new stuff like chemical bonds and working through that. So what we did in class today then is we did the guided reading, and I added a couple extra pieces of information, and then we worked on doing diagramming, Lewis dot diagram. Each dot represents a valence electron. And valence electrons are the outermost electrons that are responsible for any bonding that takes place. And the purpose is to end up with an octet to act like the noble gases. The noble gases are stable because each electron is paired. And there's 4 pairs for an octet, 8, right? So the way you know how many valence electrons is that you look at the group number. So group number 1 has 1. Group number 2 has 2. Group number 3 has, or group number 13 has 3. We skip the transitions, and there's 10 of those. 3 through 12, those are 10 groups. So group 1 has 1, group 2 has 2, group 13, 3, group 14, 4, group 15, 5, group 16, 6, group 17, 7, group 18, 8. Except for helium. Helium only has 2 electrons. Fills up at 2, and that was in your reading. All right, so we practiced using oxygen. So you find oxygen on the periodic table. Oxygen is in group, I'm going to use a different marker. Oxygen is in group 16. Group 16 has 6 valence electrons. This is the pattern that you have to follow. First, you write the symbol correctly. Oxygen symbol is a capital O. Then you have to follow this pattern. Okay? You go top, right, bottom, left, and you keep going until you get the number you're supposed to get. Oxygen is group 16, so it needs 6. So I go top and right. Boom. I'm done. Okay? Here's where we're headed. These 2 are unpaired, so we're going to say, okay, so how can we pair these 2 and get a bond? Well, maybe you've seen this before. This is H2O, a water molecule. That's where we're headed. You don't have to write all that extra. That's where we're headed. That's why we're doing these dot diagrams, to see who needs what and how we can fix that. So, oxygen had 2 unpaired electrons. Boom. Had 2 unpaired, so it's going to need 2. Because it was in group 16. All right. Nitrogen is in group 15. Its symbol is a capital N. And then you go 1, 2, 3, 4, 5. So it needs 1, 2, 3 electrons for it to be stable. Do you see it? Potassium is in group 1. Group 1 will have 1. Potassium's symbol is a capital K. And this 1 valence electron is why that group is so highly reactive. It is going around the world trying to get rid of that electron. Get rid of it, get rid of it. It's out there all by itself, it's causing a problem. It's easier to get rid of 1 than to try to take in 7, right? Get rid of 1 or take in 7, find 7. Get rid of 1, it's highly reactive. Who could it get rid of 1 to? It could give 1 away to group 17. So let's look at iodine. Iodine is in group 17. So how many electrons are unpaired? Just 1. If that went down there, I could make an ionic bond. Sodium chloride, I know you've heard of it, table salt. Sodium is in group 1, chlorine is in group 17. It's a match made in heaven. Okay, so that's where we're going with it, but we're not there yet, but that's where we're going. That's why we're doing these. See, Who needs what? He needs to get rid of one. He needs to take in one. Okay, group 17, group 1. The last one that we haven't done that I wanted to make sure we went through today is beryllium. And the reason I want to make sure we do beryllium is because make sure that you write the symbol correctly. It's capital B, lowercase e. It's in group 2, so it's 1, 2, beryllium. Sometimes group 2 you'll see them written this way. And it's really not that it's wrong. It's just if for all the other stuff that we are going to be doing, if you follow that pattern that we were doing, most of the time, about 90% of the time, that's what you need to do is follow that pattern so you can see who needs a partner. Okay? So beryllium, we're writing them this way. And again, it's probably going to be easier for beryllium to get rid of 2 than to try to find 6. Okay? All right. Reach out to me if you have any questions.